Today we are going to learn reverse osmosis, an ideal system of water softening. Water used in textile wet processing contain different groups of impurities such as suspended solids, total dissolved solids, different ions like sodium, calcium, iron, chlorine, different microorganisms such as virus and bacteria, complex of sulfate, carbonate and bicarbonates, coloring matter and free carbon dioxide. These all impurities create lot of problem during actual processing of textile, and that's why we have to remove them from the water, and such term is known as water softening. In any process, separation process, membrane is used. Water coming from one side passes through membrane and we get the treated or pure water by the removal of different groups of impurities from the water. Such process is known as a separation process, and this is the general representation of membrane separation process. Basically, there are four types of membrane-based separation process are widely used, such as microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. These all processes are differ from each other because they remove different size of impurities from the water. This is graphical representation of all types of separation based process, and we clearly see that reverse osmosis process remove all types of impurities from the water. Means reverse osmosis remove smallest impurities from the water which cannot be removed from the earlier process, and that's why it is widely used nowadays. The common difference between other filtration process and reverse osmosis process are as follow. Other filtration process, separation is made by sieving mechanism, while in reverse osmosis separation is made by osmosis mechanisms. Other filtration process, membrane passes smaller particles and retains larger one, while in reverse osmosis membrane passes only solvent and retains the solute. Other filtration process use to remove suspended particles from the water, while reverse osmosis is used to remove dissolved particles as well as suspended particles from the water. Why reverse osmosis? Water is used as a universal solvent and it contains one or more groups of impurities. The term water purification refers to removing all kinds of impurities from the water, means remove all types of impurities from the water. There are numbers of methods are used for water purification, but scientifically there are three methods are recognized. First one is a reverse osmosis, second one is a freeze thawing, and third one is a distillation, and that's why reverse osmosis is widely used nowadays in industry. Before going to reverse osmosis, we have to understand the concept of osmosis. Now, what is osmosis? Osmosis is the natural tendency to balance the chemical potential of liquid on both sides of the membrane. Flow always moves from lower to highly concentrated side during the process. The concentration difference of liquid is responsible for movement of liquid flow. During the separation process, membrane is a barrier to remove different groups of impurities from the water. Now see, what is reverse osmosis? It is a process in which high pressure greater than natural osmotic pressure is applied on the high concentration side of the membrane. Additional high pressure forcing the water to travel through the membrane from higher to lower concentrated chamber or concentrated site. Thus, reverse osmosis is reversing the natural tendency of water flow, and that's why it is known as reverse osmosis, because we reverse the natural tendency of water. Okay, and that's why it is known as a reverse osmosis. Okay, let's see from the figure. This is the lower side in chamber and this is the higher concentration side of chamber. Water coming from this side passes through membrane and goes to the higher concentration side. This is the natural tendency of water that it goes from lower side to the higher concentrated side, which is known as a osmosis, and this is due to this osmotic pressure. Now what happens in the reverse osmosis? We applied additional pressure on the higher concentrated side and force the water. That's why it is passes through membrane and goes to the lower concentrated side of the chamber. So we reverse the natural tendency, that is osmosis of the water, and that's why it is known as a reverse osmosis process. This is the horizontal figure of the reverse osmosis concept. Water coming from the left side under pressure passes through membrane and we get the pure water on the right hand side, and different groups of impurities retained by the membrane. Membrane is a selective barrier for any separation process. Purification of liquid is done by combination of membrane and diffusion mechanism. Membrane can separate particles and molecules as per particle size and molecular weight. So membrane is a very important barrier for any separation process and also for reverse osmosis. Such type of membrane is used in the reverse osmosis process. The membrane used in the reverse osmosis process made of different layers and numbers of layers of polymeric materials. Water passes through these different layers and removes different groups of impurities by trapping inside the layers, and we get the pure water. Basically, there are three types of membranes are used. One membrane is made from cellulosic materials, another made from fully aromatic polyamides, and third made from thin film composite materials. These all types of membranes are widely used, and they use for different size of particles. Reverse osmosis applications used in different areas. It is used for waste water recycling. It is used in the industrial water purification. It is used for food and dairy product. It is used in the laboratory. It is used in the municipal water purification. It is used in the medical sector. It is used in the pharmaceutical sector. So reverse osmosis process is widely used nowadays by the industry. In reverse osmosis, there are two methods or two types are used. First one is a single pass reverse osmosis process. In this, water coming from one side passes through membrane, and on the other side we get the pure waters, and different groups of impurities removed by membrane and removed from the water. So this concept is known as a single pass RO, and this is widely used at a home drinking RO system. Another concept is a double pass RO. Okay, what happens in this process? Different membranes are arranged in a series parallel to each other. So water passes through different membranes and we get the pure waters. Okay, by this double pass RO system we get purify the water in a bulk quantity, and so that's why this process is widely used by the industry. Okay, this is the drinking water RO systems we widely see at the home, and it is operating on the single pass RO system. This is industrial RO systems. Okay, we see different membranes are arranged parallel to each others, and water passes from it and we get the purified water in the bulk quantity. This is operated on basis of double pass RO system. There are some limitations of RO process. RO process cannot remove chlorine and volatile organic chemicals which are smaller than water molecules. RO system can produce only 15 gallons per day purified water. So this process is fairly slow. The maintenance of the RO system must be done regularly. Otherwise, there are a lot of problems during process. The RO membrane should be replaced every 2 to 3 years. Due to high pressure requirement, RO is usually not applicable for highly concentrated solution. This is one of the biggest limitations. The RO process usually cannot be applied without pre-treatments. Means when we purify some water by the RO system, we have to pre-treated such waters, so we minimize the load on the RO. Thank you.